Hi everybody, today I'll show you how to do problem number 3 from chapter 7. It states, Batman, whose mass is 80 kilograms, is dangling on the free end of a 12-meter rope, the other end of which is fixed to a tree limb above. By repeatedly bending at the waist, he is able to get the rope in motion, eventually making it swing enough that he can reach a ledge when the rope makes a 60-degree angle with the vertical. How much work was done by the gravitational force on Batman in this maneuver? So, I've drawn my diagram here. I'm going to zoom out. Okay, so in this diagram here, we're going to say Batman starts at the bottom of the vertical right here, and he swings up to the ledge, which he is over here. To do this, the rope makes a 60-degree angle, so I've drawn the rope right here, calling it length R, because it's and since he's swinging on the rope, he's going in a circular motion. And we are given in the problem that his mass is 80 kilograms. The length of the rope, R, is 12 meters. And I've labeled his displacement from the bottom to the ledge as delta x. So to find the work done by the gravitational force, we can use this equation. W is equal to Fx cosine theta. And the gravitational force is just another way of saying the weight, which is mg. So we're going to substitute that in. So here we know what the mass is because it's given, and we know what g is. So to find x, we can look back at this diagram, and we notice that these two lengths are equal. So that means this must be an isosceles triangle. So I'm going to draw that here, where this is 60 degrees. That's length R, that's length R. They're both equal, so that means these two angles down here must be equal. So now we can figure out that these two angles must be 60 degrees, which I'll label in over here also. And that shows us that this triangle that we've drawn is actually an equilateral triangle, meaning that these two lengths are length R. This third side must also be length R. So we can substitute that into the equation now, where delta x is equal to R. Now, how to find theta? In this equation, or this formula, theta is equal to the angle between the force and the displacement. So we can see here, this angle, theta, is actually this angle right here, the angle between the force and the direction of the displacement. And we can see that this force is going down, and this right here is 60 degrees. So knowing that these are supplementary angles, theta must be 120 degrees. So now we know what all our variables are, so we can start substituting that in. Mass, which was given to us, is 80 kilograms. G is the acceleration due to gravity, which is 9.8 meters per second squared. R is the length of the rope, which was given to us, 12 meters. And cosine theta is 120 degrees. Now we plug that all into our calculator, we'll get negative 4,704 joules, which is equal to negative 4.704 kilojoules. And that is your final answer.